Lesson 12.7 is on the probability of compound events. I know it says something else there. So, in this lesson, you will learn to find the probabilities of independent and dependent events, and then find probabilities of mutually exclusive events. Okay, so if two events, A and B, are independent, then the probability of both events occurring is the product of the probability of A and the probability of B. So if I want to know the probability of A and B happening, both, I find the probability A, and I multiply by the probability of B, and that's going to give me the probability of A and B happening. So in this case here, Ray is flying from Birmingham to Chicago on a flight with a 90% on-time record. On the same day, the chances of rain in Denver are predicted to be 50%. What is the probability that Ray's flight will be on time and that it will rain in Denver? Okay, so I want to know the probability of rain. So we know P represents the probability of on time and with rain. So the thing says that the probability of it being on time times the probability of rain. So the probability of being on time is 90%. So we're going to put this as 0.9. And the probability of it raining is 50%. So I'm going to put that as 0.5. And I just multiply those two numbers together. So 0.9 times 0.5 I get 0.45. So we can say there's a 45% chance that it will be on time and that it will rain in Denver. Okay, you guys try this one. Okay, probability of dependent events. In two events, A and B are dependent. Then the probability of both events occurring is the product of the probability A and the probability of B after A occurs. So, if what happens in B depends on what happened in A, then we're going to do the probability of A times the probability of B happening after A has already happened. So let's look at an example of this so that you can see what this looks like. So, at the school carnival, winners in the ring toss game are randomly given a prize from a bag that contains 4 sunglasses, 6 hairbrushes, and 5 keychains. 3 prizes are randomly drawn from a bag and not replaced. Find P of sunglasses, hairbrush, and keychain. Okay, so when I want to find the probability that the sunglasses are picked first, then the hairbrush, and then the keychain. So if the sunglasses are picked first, there's a 4 out of, altogether I have 4, 6, and 5. So a total of 15 things. So 4 out of 15 items is the probability that I'm picking sunglasses. Now, I already picked the sunglasses. So now I have a total of 14 things left to choose from. And I want to know the probability of it being a hairbrush. And there are 6 hairbrushes. I haven't lost one of them. So I'm going to do times 6. Okay? And now I have 13 items to choose from. Okay? And I want to know the probability of it being a keychain. And there was 5 keychains. So this is going to be the probability of picking those 3 things. So I'm going to do 4 times 6 times 5. And I get 120. And then I do 15 times 14 times 13. And I get 2,730. And so then I just want to divide those if I can. And that reduces to 4 over 91. So there's a 4 out of 91 chance of picking sunglasses, then a hairbrush, and then a keychain. Okay, for the second one, what if I want to find the probability of finding a hairbrush, and then not a hairbrush? Okay, so the first thing I look at is the probability of finding a hairbrush. So again, there are 6 hairbrushes out of a total of 15 things. Now I've already picked 1 hairbrush, and I want to pick another hairbrush. So now I'm out of 14. I have a total of 14 options. So, but I don't have 6 hairbrushes anymore. One was already picked. Now I have 5 hairbrushes. Okay, and now I want to know what I have 13 items left, and I want to know the probability of not picking a hairbrush. So that would be sunglasses or keychains, which would be a total of 9. So this is going to be the probability of picking a hairbrush and then a hairbrush and then a non-hairbrush. So I do 5 times 6 times 9, and I get 270. And then I do 15 times 14 times 13, which I just did before, and have gotten 2,730. Okay, and I simplify, and I get 9 out of 91. Okay, so there's a 9 out of 91 chance of picking those items in that order. You guys find the probability of picking a red, a green, and a blue. And then a green, blue, and not red. Okay, mutually exclusive events. If 2 events, A and B, are mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities. So we're not saying that A and B both have to occur, we're just saying what's the probability that this is going to happen or this is going to happen. So we find the probability of A, and we find the probability of B, and we add them together, and that's going to be the total probability that either one of them might happen. Okay, so for example, a card is being drawn from a standard deck. Find the probability of picking a 7 or picking an 8. Okay, so for picking a 7, it's going to be the same thing as the probability of picking 7 plus the probability of picking an 8. So in a deck of cards, there's a total of 52 cards, and 4 of them are going to be a 7, and there's a possibility of 4 out of 52 for an 8. Okay, so altogether I get 8 out of 52, which reduces to 4 over 26, or 2 over 13. So 2 out of 13 would be the probability of picking a 7 or an 8. A card is being drawn from a standard deck. Find the probability of P being neither club nor heart. Okay, so that means if it's not a club or a heart, that's going to be the same thing as the probability of being a spade or a diamond. So the probability of a spade, whenever we have that or, is when we're doing plus, or the probability of a diamond. So probability of a spade, there's 13 out of 52 spades and 13 out of 52 diamonds. So it makes a total out of 26 out of 52, or 1/2. So the probability is 50% that you're going to pick a neither club nor heart, which would be the same as a spade or a diamond. Okay, so you guys do this one. And this one. Okay, probability of events that are not mutually exclusive. If 2 events, A and B, are not mutually exclusive, then the probability that either A or B occurs is the sum of the probabilities decreased by the probability of both occurring. Okay, so if 2 events are not mutually exclusive, then the probability. Okay, so in this case, in the game of bingo, balls or tiles are numbered 1 through 75. These numbers correspond to columns on a bingo card, as shown in the table. A number is selected at random. What is the probability that it is a multiple of 5 or is in the column N? So the reason these are not mutually exclusive is because they overlap. So something could be a multiple of 5 and be in column N. So when you do this, if you were to just take this, if you're trying to find the probability of multiple of 5 or in N, right, you would think that this is going to be the probability of the multiple of 5 plus the probability of being in N. But because there's an overlap, the probability of something is going to be picked twice. So like in N, for example, 35, 40, and 45 are both multiples of 5 and in N. So they get counted twice. So I want to subtract the probability. I want to subtract it out once because it got counted twice. So I want to take it out. So I'm going to take out the probability of multiple of 5 and in N. Okay, so if we have numbers between 1 and 75, how many numbers are multiples of 5? Okay, in each of these sections, there's 3 numbers that are multiples of 5. So in this one, it's 5, 10, and 15. This one, it's 20, 25, and 30. Right? So each of these has 3, and there's 5 sections. So there's going to be a total of 15. So the probability of picking a multiple of 5 is 15 out of 75. Okay? And then I want to find the probability of being in N. So how many numbers are in N? So we have 31 through 45, which is also 15 numbers. So there's 15 out of 75 is a probability of being in N. But there's those 3 numbers that count out for both. So I'm going to subtract out 3 out of 75 because those 3 numbers got counted here and here. So I'm going to take it out one time. So it only would be counted once. So then I do this. So 15 plus 15 is 30 minus 3 is going to be 27 out of 75. Okay, so 27 over 75 reduces to 9 out of 25. Okay, so the probability is 9 out of 25 that you would choose a number that's 5 or in N, multiple of 5 or in N. Okay, you guys do this one. And that is the end of lesson 12.7.